Hello everyone. In this video we will discuss about the mesh analysis. So this is a given circuit and the question is determine the mesh currents I1, I2 and I3 using mesh analysis. So here we have three unknown currents I1, I2 and I3. So we have to assume the direction for these currents. We have three meshes, so we are assuming three mesh currents I1, I2 and I3. Okay. So we have to assume these currents in clockwise direction only because it will minimize certain errors. So once we have assumed the current direction, we have to write down Kirchoff's voltage law equation. So we already know that by Kirchoff's voltage law, sum of the voltage rise equal to sum of the voltage drops in a closed circuit. So voltage rise is written with respect to voltage source only. If the direction of the assumed current direction is from negative to positive with respect to voltage source, then it is considered as voltage rise. So on the other hand, voltage drop, if the current direction is assumed to be from positive to negative with respect to voltage source, then it is considered as voltage drop. So next, the voltages across all the resistors are considered as voltage drops only. So this voltage drop across the resistors are given by Ohm's law. V is equal to I into R. Okay. So first we'll consider mesh 1. Here we have three meshes, so we have to write three mesh equations. So first we'll write the mesh equation for the first mesh. Okay, we have to find out the voltage drop and voltage rise, and then we have to equate them in order to obtain this Kirchoff's voltage law equation. Okay, so in mesh 1 we have 7 volt source, 1 ohm resistor, 6 volt source and 2 ohms resistor. So we have to consider all the elements and we have to write the voltage rise and voltage drop. So this current is flowing in the clockwise direction. So with respect to this 7 volt source, this current is flowing from negative to positive. Okay, if the current direction is from negative to positive, then it is considered as voltage riser. So we can write the voltage rise as 7 volts. So we have one more voltage source. If we consider the same current direction, that is I1, here the current flows in the downward direction, that is from positive to negative. So if the current direction is from positive to negative with respect to voltage source, then that particular value of the voltage source is considered as the voltage drop only. Okay. So next we have to write the voltage drop across the resistors. So first we'll consider 1 ohm resistor. So this 1 ohm resistor is lying in between mesh 1 and mesh 2. In mesh 1 we have I1 flowing in the downward direction. In mesh 2 we have I2 flowing in the upward direction. Both these currents are in the opposite directions. So the net current will be the difference between I1 and I2. So we can write either I1 minus I2 or I2 minus I1. So since we are writing the equation for mesh 1, we have to consider the current as I1 minus I2. So this is the total current. So total current multiplied by the resistance value will give you the voltage drop. So this is nothing but I1 minus I2. So next we have to write the voltage drop across 2 ohms resistor. So similarly this 2 ohms resistor is lying in between mesh 1 and mesh 2. So in mesh 1 this current I1 is flowing downward through this 2 ohms resistor and I3 is flowing in the upward direction. Okay, this is also in clockwise. So both these currents are in the opposite directions. So the net current can be I1 minus I3 or I3 minus I1. Since we are writing for mesh 1, we have to write it as I1 minus I3 multiplied by 2. Okay, so we'll get 2I1 minus 2I3. So we have these three voltage drops and one voltage rise. So now we have to add all the voltage drops. So sum of the voltage drops is equal to 6 plus I1 minus I2 plus 2I1 minus 2I3. So on simplification, we will get 6 plus 3I1 minus I2 minus 2I3. So now we'll write the Kirchoff's voltage law. So by Kirchoff's voltage law, sum of the voltage rise equal to sum of the voltage drop. Sum of the voltage drop equal to voltage rise. Okay. So we can write it as 3I1 minus I2 minus 2I3 plus 6 equal to 7. or 3I1 minus I2 minus 2I3 equal to 7 minus 6 equal to 1. So this is equation number 1. Next we have to write the mesh 2 equation. Similar to mesh 1, we have to write the voltage drop and voltage rise for mesh 2. So in mesh 2 we have 1 ohms resistor, 2 ohms resistor and 3 ohms resistor. So we don't have any voltage source. So we can write voltage rise directly as 0. So next we have to find out the voltage drop across each and every resistor. So first we'll write for 1 ohm resistor. So as we already discussed, this 1 ohm resistor lies in between mesh 1 and mesh 2. So this mesh 1 current flows in this direction and mesh 2 in the opposite direction as already discussed. Okay. So now since we are writing for mesh 2, we have to consider the current flowing through this resistor as I2 minus I1 multiplied by 1. This is equal to I2 minus I1. So next we have to write the voltage drop across 2 ohms resistor. So current flowing through this 2 ohms resistor is I2. So I2 multiplied by 2, this is equal to 2 into I2. So next voltage drop across 3 ohms resistor. So this 3 ohms resistor is lying in between mesh 2 and mesh 3. So this mesh 2 current is flowing from right to left, whereas this mesh 3 current is flowing in the opposite direction. So the net current will be I2 minus I3 while writing for mesh 2. So this current is I2 minus I3 multiplied by 3. So this is equal to 3I2 minus 3I3. Okay. So now we have to add all the voltage drops. So sum of the voltage drops is equal to I2 minus I1 plus 2I2 plus 3I2 minus 3I3. So on simplification we will get minus I1 plus 6I2 minus 3I3. So now by Kirchoff's voltage law, sum of the voltage rise is equal to sum of the voltage drops. So we can equate this sum of voltage drop to the voltage rise. Okay. So minus I1 plus 6I2 minus 3I3 equal to 0. So this is equation number 2. So next we'll write mesh 3 equation. So in mesh 3 we have 6 volt source, 2 ohms resistor, 3 ohms resistor and 1 ohm resistor. Okay. So again this I3 is flowing in the clockwise direction. Now we have to write down the voltage rise and voltage drop. So here we have one 6 volt source. So if we see the direction of this I3 is flowing from negative to positive. So then it is considered as voltage rise. So next we have to write down the voltage drop across all the resistors. So first we'll write for 2 ohms resistor. Okay. So as discussed earlier, this 2 ohms resistor is lying in between mesh 1 and mesh 2. So mesh 1 and mesh 3, mesh 1 current is flowing in the downward direction. Mesh 3 current is flowing in the opposite direction. So this is mesh 3 equation. So we have to write it as I3 minus I1. Okay, while writing for mesh 1, we have written it as I1 minus I3. So multiplied by 2 will give you minus 2I1 plus 2I3. So next we have to write the voltage drop across 3 ohms resistor. So this 3 ohms resistor is lying in between mesh 2 and mesh 3. So mesh 2 current is flowing this way and mesh 3 current in the opposite direction. So the net current is I3. Since we are writing for mesh 3, we have to write it as I3 minus I2 multiplied by 3. So on multiplication, we'll get 3I3 minus 3I2. So next we have to write down the voltage drop across 1 ohm resistor. So current flowing through this 1 ohm resistor is I3 only. So I3 into 1. This is equal to I3. So now we have to add all the voltage drops. So sum of the voltage drop is equal to minus 2I1 plus 2I3 plus 3I3 minus 3I2 plus I3. So this is equal to minus 2I1 minus 3I2 plus 6I3. So now by Kirchoff's voltage law, sum of the voltage rise is equal to sum of the voltage drops. So we have to equate this summation of voltage drop to voltage rise. So this will be minus 2I1 minus 3I2 plus 6I3 equal to 6. So this is equation number 3. So these are the three equations what we have obtained. Now we'll solve these three equations. So for solving these three equations, we can use Cramer's rule. Okay. So in Cramer's rule, we can write these equations in the matrix form. So the first matrix is the resistance matrix multiplied by the current matrix. So that will give you that will be equal to the voltage matrix. Okay. So here in the first row, we have to write the coefficients of I1, I2 and I3 of the first equation. Okay. So coefficient of I1 is 3, I2 is minus 1 and I3 is minus 2. On the right hand side, we have 1. Okay. Similarly, in the second row, we have to write the coefficients of second equation. Minus 1 plus 6 and minus 3. So here on the right hand side we have 0. Next in the third row we have to write down the coefficients of third equation. So that is minus 2, minus 3 and plus 6. Okay, equal to, on the right hand side we have 6. Okay, so this is the matrix obtained from this three equation. So first for finding out the current values, we have to find out the delta value. So delta is nothing but the determinant of the resistance matrix. Okay, so we have to find out the determinant of this resistance matrix. Minus 1, 6, minus 3, minus 2, minus 3 and 6. Okay, so this will be equal to 3 into 36 minus 9 plus 1 into minus 6 minus 6 minus 2 into 3 plus 12. So on simplification, we will get delta value as 39. Okay. So next we have to find out delta I1. Okay. So delta I1. So this is again the determinant of the resistance matrix by replacing this first column with the right hand side matrix. Okay. So for finding out I1, we have to replace the first column with the right hand side matrix. So right hand side we have 1, 0 and 6. Okay. So the other two columns will remain the same. Minus 1, 6, minus 3. So minus 2, minus 3 and 6. Okay. So now we can write this as 1 into 36 minus 9 plus 1 into 0 plus 18 minus 2 into 0 minus 36. So on simplification, this delta I2 will be equal to 117. Delta I1 will be equal to 117. Now I1 is equal to delta I1 divided by delta. So 117 divided by 39 will be equal to 3 ampere. So next we have to find out I2 and I3 value. For that we have to find out delta I2 and delta I3. So for finding out delta I2, we have to replace the second column with the right hand side matrix. For finding out delta I3, we have to replace the third column with the right hand side matrix. Okay, rest of the procedure will be the same. So now we have to find out the determinant value. So 3 into 0 plus 18 minus 1 into minus 6 minus 6 minus 2 into minus 6 minus 0. So on simplification, this delta I2 will be equal to 78. So now I2 is equal to delta I2 divided by delta. So 78 divided by 39, this is equal to 2 ampere. So now for delta I3, we have replaced the third column with the right hand side matrix. First two columns will remain the same. So now we have to find out the determinant value. So 3 into 36 minus 0 plus 1 into minus 6 minus 0 plus 1 into 3 plus 12. So on simplification, this delta I3 will be equal to 117. So now I3 is equal to delta I3 divided by delta. So 117 divided by 39 will be equal to 3. So now we'll solve the second problem. Here this is a given circuit and the question is determine the current flowing through 2 ohms resistor using mesh analysis. We have to find out current flowing through this 2 ohms resistor. Okay. So before that we have one current source connected in parallel with the 10 ohms resistor. So first we have to convert this current source into its equivalent voltage source. So whenever a current source is connected in parallel with a resistor, that can be converted into its equivalent voltage source in series with the same value of the resistor. Suppose I is the current value and R is the resistance, then it can be converted into its voltage source V given by Ohm's law I into R, and it is connected in series with the same value of the resistor R. Okay, so the positive and negative terminal are connected depending upon the arrow direction. Okay, if the arrowhead is pointing upward, then the upper terminal should be positive and the lower terminal should be negative. On the other hand, if the arrowhead is pointing downwards, okay, then the negative terminal should be connected in the upper terminal and the positive to the lower terminal. Okay, so in our case, this arrow direction is from right to left. So this positive terminal of the supply voltage or the equivalent voltage should be connected on the left side and the negative terminal should be on the right hand side. And the voltage V is equal to I into R, that is 8 into 10. Okay, in this case I value is 8 and the resistance value is 10. So 80 volts is connected in series with the 10 ohms resistor. So now the equivalent circuit will become like this. Okay, here we have two voltage sources. One is 100 volts, another one is 80 volts, and we have three meshes. Okay, this is mesh 1, mesh 2 and mesh 3. Okay, in mesh 1 we have 100 volt source, 8 ohms resistor and 4 ohms resistor. In mesh 2 we have 4 ohms, 2 ohms and 3 ohms resistor, and again in mesh 3 we have 3 ohms, 80 volt source, and then 100 ohms and 5 ohms. So these two are connected in series. We can add these together, or we can simply solve by considering these two as such. Okay, so now we will have to assume three currents, I1, I2 and I3. So I1 is the mesh 1 current, I2 is the mesh 2 current, and I3 is the mesh 3 current. All these currents are assumed to be flowing in the clockwise direction. Okay, it is advisable to assume always in the negative direction. So now we'll write the mesh equation for mesh 1. Okay, so as usual we have to write the voltage rise and voltage drop. So here voltage rise is equal to 100. So because the current direction is from negative to positive. Okay, this I1 is flowing from negative to positive with respect to this voltage source. So it is considered as voltage rise. So next we have to write down the voltage drop across all the resistors. So first we'll write for 8 ohms resistor. The current flowing through this 8 ohms resistor is I1. So I1 into 8 is equal to 8 into I1. So next 4 ohm resistor, voltage drop across 4 ohms resistor. So this 4 ohms resistor is lying in between mesh 1 and mesh 2. So here from mesh 1 current is flowing in the downward direction, and from mesh 2 current is flowing in the upward direction. Both the currents are in the opposite directions. So the net current flowing through this 4 ohms resistor is either I1 minus I2 or I2 minus I1. So while writing for mesh 1, we have to consider the current as I1 minus I2. And if we are writing for mesh 2, we have to consider the other way, that is I2 minus I1 into 4. So this is equal to 4 I1 minus 4 I2. Okay, we have only 3 elements. So now we have to add all the voltage drops. That is equal to 8 I1 plus 4I1 minus 4I2. So on simplification we will get 12I1 minus 4I2. So now by Kirchoff's voltage law we can write sum of the voltage drop is equal to sum of the voltage rise. So here voltage drop is 12I1 minus 4I2 and the voltage rise is 100. So this is equation number 1. So next we'll write for mesh 2. So here in mesh 2 we don't have any voltage source. Okay, we have only resistors. So we can write voltage rise is equal to 0 directly. So now we have to write the voltage drop across each resistors. So now voltage drop across 4 ohm resistor, as already discussed, current flowing through this 4 ohm is the difference between I1 and I2. So while writing for mesh 1 we have written as I1 minus I2. Now we have to write it as I2 minus I1 multiplied by 4. So this can be written as 4I2 minus 4I1. So next voltage drop across 2 ohms resistor. So current flowing through this 2 ohms resistor is I2 only. So I2 into 2. So 2 into I2. So next voltage drop across 3 ohms resistor. So this 3 ohms resistor is lying in between mesh 2 and mesh 3. So here I2 is flowing in the downward direction and I3 is flowing in the upward direction. Both these currents are in the opposite direction. So the net current flowing through this 3 ohms resistor is I2 minus I3 or I3 minus I2. So we are considering mesh 2. So we have to write it as I2 minus I3 multiplied by 3. So this is equal to 3I2 minus 3I3. So now we have to add all the voltage drops. So sum of the voltage drop is equal to 4I2 minus 4I1 plus 2I2 plus 3I2 minus 3I3. So on simplification we will get minus 4I1 plus 9I2 minus 3I3. So now by Kirchoff's voltage law, sum of the voltage drop is equal to sum of voltage rise. Here voltage drop is minus 4I1 plus 9I2 minus 3I3. This will be equal to voltage rise, that is 0. So this is equation number 2. Next we'll write the equation for mesh 3. So in mesh 3 we have one voltage source, this 80 volts and 3 resistors. So if we see this I3 is flowing in the clockwise direction. It is flowing from positive to negative. Okay, this way. From positive to negative with respect to this 80 volt source. So this 80 volt source is considered as voltage drop only. Okay. So in this case we don't have any voltage rise. So we can write it as 0. Okay. So next voltage drop across 10 ohms resistor. So current flowing through this 10 ohms again is I3. So we can write it as I3 into 10 or 10 I3. So next voltage drop across 5 ohms resistor. So I3 current flowing through this 5 ohms is I3 again. So 5 into I3. So next voltage drop across 3 ohms resistor. So 3 ohms resistor is lying in between mesh 2 and mesh 3 as already discussed. Okay. So the now net current flowing through this 3 ohms resistor is written as I3 minus I2 multiplied by 3. This is equal to 3I3 minus 3I2. So now we have to add all the voltage drops. So sum of the voltage drop is equal to 80 plus 10I3 plus 5I3 plus 3I3 minus 3I2. Okay. On simplification it is written as 10 plus 18I3 minus 3I2. So now by Kirchoff's voltage law, this sum of the voltage drop will be equal to voltage rise. So 80 plus 18I3 minus 3I3 equal to 0. Or this can be written as, so this is 3I2. So this can be written as minus 3I2 plus 18I3 equal to minus 80. So this is equation number 3. Now our aim is to find out the current flowing through this 2 ohms resistor, that is I2. Okay. So these three are the equations what we have derived and we can write it in the matrix form. Okay, as already discussed. So this is a resistance matrix, this is a current matrix and this is the voltage matrix. Okay, we have to write the coefficients of I1, I2 and I3 of the first equation in the first row, and second equation in the second row, and third equation in the third row, and this value, the right hand side value is written on the right hand side. Okay, so this resistance matrix, general form of this resistance matrix is R11, R12, R13, R21, R22, R23. Similarly, R31, R32 and R33. So multiplied by unknown values of currents I1, I2, I3 equal to voltages V1, V2, V3. Okay. So here the diagonal elements R11, R22, R33 are the sum of the resistors in individual meshes. So if you see here, in mesh 1 we have two resistors, that is 8 ohms and 4 ohms. So if we add these two, 8 plus 4 is 12. Okay, this is R11. So next, similarly, R22 is sum of the resistors in mesh 2. So in mesh 2 we have 4 ohms, 2 ohms and 3 ohms. So 4 plus 2 plus 3, 9. Okay, here. So next, R33 is sum of the resistors in mesh 3. In mesh 3 we have 3 ohms, 10 ohms and 5 ohms. So 3 plus 10 plus 5 is 18. Okay. So these diagonal elements are some of the resistors of the individual meshes. So now this off diagonal elements R11, R21 and R12. So these two are the common element between mesh 1 and 2 with the negative sign. So in between mesh 1 and 2 we have 4 ohms resistor. So here minus 4 and minus 4. Okay. Similarly, R13 and R31 are the common elements between mesh 1 and 3 with the negative sign. Here in between mesh 1 and 3 we don't have any common element, so we have to put 0 here. So next, R23 and R32 common element between mesh 2 and 3 with the negative sign. So here in between mesh 2 and 3 we have 3 ohms resistor. So here we have minus 3 multiplied by the mesh currents I1, I2, I3 equal to, here we have to write the voltage rise as such, and if it is voltage drop we have to add a negative sign. So if you see here in mesh 1 the current is flowing from negative to positive, this is voltage rise. So we have to write it as such. In mesh 2 we don't have any voltage source, so this is 0. In mesh 2, and in mesh 3 the current direction is from positive to negative. Okay, this is considered as voltage drop, so we have to add in a negative sign here. Okay, so this matrix can be written directly by inspecting the circuit itself. So now we'll solve this problem. Our aim is to find out the current value. Okay, this is the equations we got. Now we have to apply the Cramer's rule. So first we have to find out the delta value, that is the determinant for the resistance matrix. Okay, minus 4, 9, minus 3, 0, minus 3 and 18. So we have to find out the determinant value. So 12 into 9 into 18 minus of minus 3 into minus 3 plus 4 into minus 4 into 18 minus 0. So on simplification, we will get 1548. So next we have to directly find out delta I2 value. For finding out delta I2 value, we have to replace the second column of the resistance matrix with the right hand side matrix. Okay. So first and third column will remain the same. So third column 0, minus 3 and 18. So now we have to find out the determinant value. So 12 into 0 minus of minus 80 into minus 3 minus 100 minus 4 into 18 minus 0. So on simplification this will become 4320. So I2 is given by delta I2 divided by delta. So 4320 divided by 1548. So this will be equal to 2.7906 ampere. So this is the answer.